Right, so we'll have another video about sort of this is how I sort of designed my my circuit. Okay, so we're starting off here. We've got the same sort of stuff, isn't it? Okay, remember this is our first one, and you can see actually we've got two batteries there. I only meant to put one in, but never mind. And you can see that it's the electrons are flowing around there. But if I break that circuit, none of them work, and it was always a nightmare with those Christmas lights having to change them. Now, so here, if I want to do the same as the last one, I would just sort of line these up here, but I'm going to do, yeah, I'm sort of join them together, but I'm going to do a different circuit for this lot. Okay, so there, so I've got my one. Okay, let me just put this up to oh, it's on 20 volts. Yeah, we'll leave it on 20 volts. Okay, so it's quite a bright light, just like it was in the last one, 20 volts. In fact, I had 40 volts in the last one, so twice the energy, but so it's still nice and bright here. Okay, so I'm not going to just build them back in where I did last time. So this time I'm going to build it up slightly differently. So I'm just going to go here. Okay, let's bring this one across here. Okay. There. 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 Okay. So I've got two going together. Okay. And let's just see if I break this circuit. So I'm just going to break the circuit up here. And what you'll notice is, even though I'm breaking the circuit up the top, up with that first one, the second one is still lit, isn't it? So when I put it back, they're still both lit. And yeah, okay. So this way, this type of circuit, it doesn't matter whether one breaks or not. And thank goodness Christmas lights are a bit more like this now, because otherwise you would spend ages. And what you'll notice is, if you follow the negative electrons, the electrons coming from, sorry, the negative side of the battery, and we're coming to the joint here. I don't know whether you can see my little this sort of pointer. And at this point, they split. Okay, so they will go there, and some will carry on. They will split there. Okay, and then they carry on and they rejoin over the other side, isn't it? They carry on, rejoin. You'll note, look at the speed. Look at the speeds of them. They seem to be going really quite fast here. Then they sort of slow down, they speed up again there. Okay, so it's really important to try to observe these. So there's two of the lights done. Okay, let's see if I can get the rest in place. So I can do that fairly quickly. Oops, don't want to do that quite yet. Okay, let's get that there. Oops, don't want to. Okay, let's bring it a bit further over. Yeah, it's getting a bit wonky. Let's use this one, shall I? Okay, good. Let's get this one out of the way. And then I can bring this over here. Now, when you're looking at these, oh, right, there we are. So now all three. And again, they're still really bright. They're still really bright. And you can see, I think they've gone even faster from the battery. Those protons leaving the negative side of the battery going even faster. They're still going quite slow then. When they get to each join, they're slowing, but then they're speeding up when they're meeting each other, aren't they? They're speeding back up. So, you know, something quite interesting happening here. Let's have a look if I break this circuit here. I break the circuits, the other two lights are still working. Let's bring on the last one, and really this is the sort of circuit that are in your homes. This is the sort of circuit really is used for pretty much everything electrical, because that series circuits, the ones we have been doing up until this point, okay, series circuits aren't actually very good in terms of practical stuff in terms of your homes. Right, remember he's being really annoying. Let's try another one, shall I? Right, okay. Bring this over, I think, to there. I don't want to join in onto that. Let's get that one out of the way. Okay, so it's still, even when we're adding these on, it's still working. Now, in terms of the name of this type of circuit, okay, now, oh, what have I done there? I must have done something wrong. Oh, I've miswired that last plug, haven't I? Okay. Okay, let's try that again. So, I need, let's cut that. Ah, there we are. Okay. The last plug, the last light. Okay, let's bring this over here. Now, good. So I need to go up to the top there. Right, okay. And they're all still really bright. They're all still as bright as as we started with, isn't it? Okay. So this is the sort of circuit used in your homes, everything, everywhere. Now, the series circuit is called a series circuit. Let's go back to it, because it's in one long series, isn't it? It's one long series. So it goes all the way around just in one loop. And this is called, have a guess. What do you reckon it's called? Look at the relationship between each one, okay? And this is called a parallel circuit, because they're sort of in parallel. Certainly when we draw them, they're in parallel. In real life, they're not kind of parallel to each other. But this is a parallel circuit. And these are the circuits really that are used all the time in your houses and things like that. Because imagine how annoying it would be if one light bulb in your house happened to pop, and then everything in the house, all the lights went off, all your electricity went just if one thing went. Whereas this way, if one thing can pop, and then other things carry on. And let's have a look at the brightness. Now here in this battery, this is only a 20-volt battery, and look how bright it's making everything. This one, I've got 40 volts. Each one has 20 volts in it, so that's 40 volts in total. And see how much slower it is. Okay, so we can see the benefits of a parallel circuit, as well as, you know, sort of if something goes wrong, it still continues. Okay, but also you have more of the brightness, don't you? You know, sort of it keeps the energy flowing. However, this battery is having to work tremendously hard. So the problem with it is this battery would run out much quicker than this battery. Okay, so it does use up more energy, but of course, you know, that's that's what we want the energy to light the bulbs, don't we? Right, okay, so on to your second task. That's also on the portal. Okay, so I want you to sort of draw the to draw both of the circuits, please, in the proper way, of course, using a pencil and a ruler. I don't want them to be drawn sort of electronically. Okay, and then there's the extension. Where I want you to have a look at the different circuits and just check the voltage and amps. Okay, I wonder what the amps on this one is. So that's 2 amps. What's the amps here? 8 amps. So look at that, and that's sort of strange. It's 2 amps, 8 amps, and we can just check the voltage, and the same on the other one. Okay, so just have a little think about how the amps are affected. It's just 1 amp on that one. Okay, that's your extension as well. All right, so back to the portal, please, and read the next challenge and have a go at the extension if you've got a chance. Okay, right, good luck with that, everyone. I'm just going to stop the recording, and I'll see you next time. All right, bye.